This is just the beginning.
Hello, my name is Sabine Flores. I'm Managing Director of the Association of Municipalities in the metropolitan area around Hanover, Braunschweig, Göttingen, Wolfsburg in Germany. This solution talk session is about platforms and data for an integrated and sustainable urban mobility. In this context, new technologies allow us to collect and manage data, which helps us to increase the understanding how people move in the cities, so that we can drive the growth of sustainable ecosystems in an intelligent and just manner. I appreciate to present today 5 experts with their interesting solutions. Let's start with Sandra Lameiras from Porto. Since 2009, Sandra Lameiras is working at Optimização of transport systems in Porto, Portugal. In 2015, she was appointed to the board of the company. Now she presents us mobility anytime, anywhere.
Good afternoon. 2 years ago in Portugal, in a city called Mafra, it was decided to build a big new health center. But there was a problem. There was no regular transport available to take people from some rural areas to this new health center. So the mayor had a problem. And the supplier of public transport that worked in that city came to our company to find a solution. So this is how Mobus came up. Mobus is a technological platform for demand responsive transport. It is working now since June in this city called Mafra. Mobus is an option on mobility as a service because being a digital solution, it follows the trends to remote access to products and services that cross all sectors in nowadays. That turns products and services available anytime, anywhere. It focuses on principles for innovation in urban mobility, such as security, safety, inclusivity, active travel, reducing pollution, and reducing engagement, reducing traffic. So, this platform includes all the necessary components to work it out. So it has 5 modules, and the first one is the system management for the operator. Here we can do all the definition of the entire network, like to put the stops, the ticket price, and the interfaces of public transport, and so on. It allows the direct interaction with the map, so we can put in an easy way and with accurate way the stops, the interface in a manual way too. It automatically generates routes between stops, and it optimizes the management of the fleet management. Like the operator can put the characteristics of the vehicles, like their size, if they are up to or not to transport people with special needs for mobilities, their consumption, and so on. It also, of course, gathers statistical data of service performance to give operators the report to be able to manage and, of course, to accurate its system. The second model is the user app. The passenger can request the services and monitor all the time his requests by remotely through mobile applications. It can also travel bookings can be performed by the mobile app web browser, or by phone call. By phone call because we don't want to left no one behind. So it means that we had to create a model for a call center. This model allows people that do not have do not use smartphones to can book by a simple phone call. So we created a call center model. The fourth model is the driver app. The driver app indicates the pickup points to provide passengers. And it also gives passengers the driver information about its passengers, and the driver gets a real-time route optimization. It includes the possibility to communicate with the client, imagine if it doesn't show up, to receive notifications about new orders in the current trip. The last model, and one of the main important, is that through advanced algorithms of route planning, the system really can consider the variety of vehicles and their condition as well as the time limitations. It also maximizes the number of delivered services while maximizing waiting times and distance between the stops. By optimizing the fleet usage, it is possible to reduce operating costs. The priority in the system is given to people that have limitations on mobility. They are the first one that can be transported. So, mobiles can incentivize public transport use because the fact of being a support for intermodal transport acts like the first mile or the last mile of the system. It also helps reduce congestion and pollution, of course, because it takes out of the road private cars. It's socially inclusive because, especially for people that have necessities for mobility, special needs for mobility, the one that lives in low-density areas, or for elderest persons, it is very important, this kind of systems. It also boosts active lifestyles because without the support of these kinds of platforms, some of these persons would not stay out of their houses, and also reduce the operating costs. To summarize, we nowadays have the challenge of with technologies to provide mobility as a services like mobiles, like DRT platforms that can really change people's life, because it makes it really easy and quickly to access to services by remote way. And this kind of platforms also can provide transport for affordable for anyone. Thank you.
Thank you, Sandra. The next one, Giacomo Fioroni, has 18 years of experience in IT and smart city project management and heads the Smart City Office of the Municipality of Trento in Italy. He managed most smart initiatives in Trento and is project manager of the European Union Horizon 2020 crowd project. Now it's your turn.
Yes, yes, yes.
No. Okay. And finally, we can start the presentation. So, hello everybody. My name is Giacomo Fioroni, and today I'd like to talk about an innovative solution to map and maintain mobility. Okay. Mobility point of interest, thanks to the engagement with local and worldwide citizens. Wow, it's impossible to use. Okay, maybe.
Yes, that's it.
No. Some technical problems, but
1 minute.
1 minute. Oh. In a very short time, we can start and restart. Okay, but I don't watch anything. Okay. Okay, I don't see anything on the screen, but there is. Okay, I can. Okay. Okay, now. Okay. So, in order to provide smart mobility services and to take data-driven decisions, and before buying IoT devices, smart mobility have to acquire an extensive knowledge about the urban mobility point of interest, such as parking spots or bike racks. Unfortunately, municipalities are often unable to know where, what type, and how many POIs there are. This is due to different reasons, like the lack of the resources to collect the information and the high cost of maintaining it up to date. These issues can be overcome by ensuring a continuous engagement of the citizen. Thanks to the European project Crowd, the municipality of Trento has developed an innovative solution based on two crowdsourcing tools, a worldwide platform to generate new data, and a local application, mobile application, to confirm the data collected. The first tool is the Virtual City Explorer, an online platform for crowd workers from all over the world. With the VCE relies on two popular tools, Figure 8 to recruit the crowd workers, and Google Street View to let them virtually explore the city, identifying the item and collect the information. But how does it work? First, the municipality defines the task, that is the items to identify and the area to explore, and provides the instruction. In this example, we are asking for finding 3 different yellow parking spots. Oops. Okay. No. Okay. Second, then the crowd workers, after reading the instruction, have to explore the city using the Google Street View. looking for the items to identify. In this example, they are looking for a yellow parking spot. Once discovered, they have to take 3 pictures from 3 different angles in order to obtain its exact coordinates. But what happens next? After the conclusion of the tasks, the new data generated by the Virtual City Explorer is verified by the municipality and acquired into the central repository. And the new data set could be fused with other existing data set, if any, and the result is a new, bigger, more accurate data set. Since the up-to-dateness of Google Street View is often unclear, a further validation of the data set could be required via the local app iLog. And the iLog app is, in fact, the second tool of our solution to send local citizens to the field to confirm the data collected. It works very similarly to the VC. In this case, users have to take geolocalized pictures of the item, providing related information such as the capacity and the type of the parking spot. To conclude, with the crowd solution, it is possible to collect and maintain up-to-date information about mobility point of interest. This provides a twofold benefit. Oh, sorry. Okay. Citizens can access to this information through the city dashboard or through other services if the municipality publish this data set as open data. On the other hand, municipality can use this valuable information to take data-driven decisions and to provide smart mobility services. Furthermore, for the municipality, it's very easy and cheap to launch as many tasks as it needs to obtain new updated information. Well, in this very short time, with some technical problem, I tried to point out the key elements of our solution, but you can find more detailed information at the links on the screen, and please feel free to contact me anytime. Thank you.
Thank you, Giacomo. Now, our next presentation is from Dirac Busquets. Didac Busquets is a computer chief scientist and has co-founded immense simulations after having spent more than 15 years doing research in the area of artificial intelligence and agent simulation. Please.
Okay, thank you. Houston? Houston? No, yeah, there's station is not there. Okay, thank you. So my name is Didac Busquets. I'm one of the co-founders of Immense and chief scientist, and I'm also leading the office here in Barcelona. So what we do at Immense, we are developing a simulation platform where we simulate urban mobility and mobility services. So the type of work that we're working on ranges from passenger mobility like taxi fleets or on-demand bus, on-demand transport, parcel movement, so logistics, and also infrastructure management to understand what happens if you close a road in a city or if you start building new developments, new housing developments that will create new mobility necessities on the area, and see what impact it has on the city itself. So what we've done is we have developed a simulation as a service platform where the users can log in, they can configure the simulation that they want, for instance, linking to the presentation by Sandra. If they want to understand what's the best configuration of a taxi fleet and how many taxis they need, they can play a bit with the size of the fleet, the type of vehicles, the type of batteries they have, or whether they are petrol. They can run simulations and then they get some feedback, and then they can make decisions before actually implementing anything. So far we have worked with many organizations, mainly in the UK and in the US, and they range from private hire companies, municipalities, infrastructure management, big corporations. And basically why we are doing all this is because the mobility ecosystem is rapidly changing. Everybody knows that. We are not in the era of just having private transport and some public transport and car manufacturers. We're seeing that this is all changing very rapidly. So we have carpooling, car sharing, we have bicycle schemes, we have scooters. We are seeing all the manufacturers actually becoming mobility service providers because they see that people is buying less cars. So there's a lot of transformation, and they need to understand how they can live in this new world. On the other side, there is all the infrastructure management authorities, infrastructure consultancies, and they need to understand how this new mobility section can be managed, whether they provide the right infrastructure, whether it's in terms of actual physical tarmac, do you have the right lanes and the right roads in your city? Do you have the right communication infrastructure for 4G, 5G, and everything that is to come? Are they prepared for autonomous vehicles? Do we know how to cope with incidents in the network? And usually these two communities have worked separately. So if I'm a fleet operator, I don't care about who manages the infrastructure. I hope that it will run correctly, but I don't really care about that. And similarly, if you're the infrastructure management, you don't really know what type of mobility services are there. You know that there are lots of cars in the infrastructure that you're managing, but you don't really know what's going on. So what we want to do with our platform is to bring these two worlds together. So if you're a fleet operator, you want to simulate what's going on with your fleet, but also what's going on in the infrastructure. So if there is an incident in the infrastructure, if there are closures, if there are communication limitations in some parts of the city, you want to know that. So what we do is we provide this simulation platform. So the first thing we do is we start with representing a virtual world, whether it's a city or a regional area in a country. And we know where the roads are, what are their characteristics. Then our platform allows the user to configure the mobility services, as I say, type of vehicles, how big they are, can they handle wheelchairs or no, how long it will take to load the wheelchair, for instance. And at the same time, they can configure what is the infrastructure looking like. So is it a standard day where everything goes more or less smoothly, or is it a strange day where there are some incidents? Is it raining? So that means that you will have more vehicles in the road probably, and less people taking the bicycle. So there are lots of different parameters that the user can configure, and then they all go to our simulation engine, which is the core of our platform. It's an agent-based simulation where we model each individual vehicle, each individual person, what their activity is during the day and how they move. And depending on the specific area that we want to simulate, if it's, for instance, for fleet operator, we simulate how the vehicles are dispatched to go and pick up the passengers and drop them off, whether ride sharing is allowed or whether it's just a single ride vehicles. So lots of parameters that the user can change. He can run lots of simulations with different parameters to test different scenarios. And that goes to all the data that is logged. The results are logged in databases so that they can be analyzed. They can understand what's going on, how is the fleet being utilized, or what's the congestion in the city. We also have live dashboards so they can actually see what's going on during the simulation. And this, the algorithms actually could be used also in real deployment of the fleet, so they could see what's going on. And to do that, we provide lots of KPIs, lots of metrics, whether it's, as I said, utilization of the fleet, waiting time for the passengers, travel time, congestion, pollution, and many other types of KPIs. And we provide this in a easy to use and friendly portal web. We want to shorten the gap between the decision making and the actual tools that are used to that, because usually in the past, we know there are lots of tools to simulate this type of things, but they are quite complicated. You need an expert in-house, or you have to actually hire a consultant to help you drive the simulations, and it's very difficult. And the turnout, the time to get answers is quite long. And what we're trying to do is provide this tool to the people that actually will make the decisions, so they can ask as many questions as they can. And the value of our tools, they are centered on the virtual representation of the city and our simulation engine, but it can provide benefits to fleet operators to better manage their fleet, to city authorities to better plan developments in the city, roadworks, for infrastructure managers, and any type of mobility service, whether it's passenger or parcels. And just to finish, this is just a post-simulation rendering of one of the simulations we did. It's in I think it's Birmingham area, where we simulated different fleets. We simulated a fleet of vehicles, getting people from the airport and getting them to one of the conference center. We simulated downtown public transport and some other fleets. And each individual point moving is one of the vehicles. The color indicates whether they are with passengers or without passengers. This is just a 3D visualization of the results of the simulation. And all the simulation results are stored in the database, as I said, so they can then be queried, and you can perform whatever analysis you want. And this is just an example of how a simulation would look like in our platform. So that was all I wanted to say. We are in Hall 1. We have a small stand there. If you want to come and say hello, you're most welcome. Thank you very much.
Sorry, I think it's wrong the laptop.
Okay.
To see, it's possible to continue.
Okay, so we continue with that. Yeah? Okay, thank you, Didac. Now we want to continue with Scott Corwin. He's a managing director leading Deloitte's Global Future of Mobility practice. For over 30 years, he was worked as a trusted consulting advisor to senior leaders to successfully undertake strategy-based transformations to address disruptive change in their sectors, markets, and communities. Okay.
Yes, I know. Thank you. Oui. I want to thank the organizers of the Smart Cities Expo World Congress for inviting me to speak. As the leader for Deloitte's Global Future of Mobility practice. I'm honored to have this opportunity to share insights from our work globally on how advances in mobility can contribute to creating a more inclusive, equitable, sustainable, and prosperous society. Deloitte works closely with private and public sector leaders around the world to shape the future of mobility ecosystem and accelerate realization of the enormous promise that it offers. Today's transportation system is increasingly fragile and struggling to keep pace with the strains of urbanization and population growth and outmoded and aging infrastructure. Most cities do not have sufficient capital to upgrade their infrastructure or modernize their existing transportation system fast enough to keep up. We cannot continue with business as usual. For the past 3 years, our team has been working closely with the World Economic Forum on catalyzing the adoption of seamless intermodal mobility, where each of us will be able to travel from point A to point B faster, cheaper, more efficiently, conveniently, and safer by using different modes that are interconnected. To make this vision a reality, cities will need an integrated system, a mobility operating system that transcends existing infrastructure, drives public and private interoperability, and interweaves transport modes to balance mobility demand with transportation supply. When we get this right, we can enable more people and goods to move faster, safer, cheaper, and cleaner than today. At Deloitte, we're working with a number of cities and regional authorities to explore how this system would function. So I am pleased today to share with you Deloitte's integral mobility.
Hopefully.
I can't hear it. The video. No? So is the video showing or not at all? There's no sound.
It's not sounding.
Okay. We'll see what happens. Yes, no? No? We Okay. Yes? No? No, okay. So I guess as we enter the 21st century, we're going back to like 100 years ago with silent movies. So, the bottom line is that integral mobility is a set of services and solutions that enable cities to dynamically influence mobility choices. It plays a key role as a city's mobility orchestrator, so city officials and private sector providers can better match transportation supply and demand, creating a more efficient equilibrium. I would invite you to come over to our booth, which is literally right there, and we will gladly replay this video with sound. My apologies on behalf of the technical team, but we're working now with a bias towards action, and I thank you very much.
Thank you, Scott. Now, last but not least, Mark Payton. Mark Payton is the Vice President of Smart Cities for the Columbus Partnership. Prior, he was the President of FactGem. He established Jobs Ohio, where he was Senior Director. Now, welcome.
Hey, at least the right first slide is up. That's a good progress. So great to be here today. I'm just going to speak to you a little bit about one of our core projects at Smart Columbus, which is a multimodal transit application that's actually up and running live. On the screen you see those are some of the participating companies. So lots of cities are thinking about, well, how could we pull multiple modes of transit into a single application to allow a resident to plan a trip across, guess what, multi-modes. So you could include walking, biking, a scooter. Our backbone transit piece is a bus system, and really trying to help people move very seamlessly across the city. It has we developed this from scratch. It's largely developed in open source code. So if you're interested in seeing it live, it's an application you can download today, on your phone or Android device. It's Coda Pivot is the name of the app. And I'm clicking ahead and I don't know what's showing next. Oh, these are the screens of the functionality. So, as I said, you can optimize and start, of course, at any point. You can pause the trip. One of the things that's key to making this all work is the cooperation of the mostly private sector vendors that are a part of this. We were very fortunate being the winner of the U.S. Department of Transportation Smart City Challenge, that when we approached these companies and said this is it's not only a demonstration project, but it's a live project deployed at scale in the city of Columbus, but we invited people to participate. And there's only one large TNC name up there that's missing. I think you could fill in the blank of who that is, but we've really gotten very good cooperation across all of our transit providers. One of the things that makes this really unique going forward is a new piece of functionality that we'll add in January, is a common payment system. So not only can you plan your trip across these multi-modes, but you can pay one time and the account will settle with each of those providers, and you only have to do it one time. Now that is a really complicated thing to do on the back end, because you're planning out a trip. Let's just take the scooter part of a trip. Maybe you're walking to a scooter, you're going to pick up that scooter, and the scooter part of the trip is 40, let's just say it's a mile. What if the person during the trip sees something they'd like to detour around? You're really trying to capture what the true heart of that trip is within certain parameters, so you're not penalizing them to take a slight detour. Now, if they go take an hour out of their way, that's a different part of the equation. The really unique thing about this common payment system, though, is it's also account-based. So you don't have to have a credit card to access this system. This is a really important part for the low-income part of our community who largely does not have credit card systems, but they do have accounts like a gift card. And what that does is it opens up these modes of transit that are credit card only, which are all the shared scooters, the shared bikes, largely all the TNC operators don't take cash. So with this account-based system, you can suddenly access all those and run it seamlessly. Now, I'm looking here. So this gives you a view of how all that works. Now, one of the really interesting things is, let's just say you're going to go ride a scooter. So we've got 4 scooter operators in our town. We limit them by how many scooters each can put in because we're trying to experiment and learn. But as a rider, I don't think many of us actually care what scooter we get on. We just want to jump on the one that's closest to where we're standing. Well, the scooter companies actually want you to prefer theirs. So that, Lime would prefer that you load their app or Bird or whatever. The way this app works is it shows all the scooters from all 4 operators, and you just pick the one that you want, and that common fare payment runs across those. So that's a really interesting, I wouldn't say tug of war, but it's been a challenge because those people want to own that user experience, and we're trying to provide something for the residents that's very, very seamless. The way the optimization works is, of course, we're paying attention to the weather, both historical and real time and traffic. So as we're trying to optimize your trip for either speed or for time, we're trying to take into account real things that are going on in the environment. You then complete the trip, and then that sort of bunch of funny boxes at the end, that takes into account all the real world experiences of that given trip and feeds it back into the system using machine learning and AI to try to optimize trips in the future to make them more realistic and better. So the system is, somewhat self-healing in that nature. The common payment system I mentioned doesn't get added to this process until January. The trip optimization engine that runs underneath this is also open source. It's Open Trip Planner, developed out of Portland. We've had great success with that. So I would encourage you, if anybody's interested, we publicize every piece of policy, procedure, document on our website at smartcolumbus.com. It's under a playbook. We were required by the Department of Transportation to publish everything, so if you're interested in it, it's all out there to share and learn from. Thank you very much.
Thank you very much. So I'm really sorry, but due to the technical problem, there's no time for our discussion, and so I can only wish you all the best. See you next year.